In this lecture, I'll help you how to learn to analyze and present the results of the network design project. So this is the most interesting part of the entire network design and modeling project. So I like this analysis phase because the learning curve in this phase is actually steep. So while analyzing the data, you will find some unique things. So always keep in mind that optimization can do anything to save even a dollar. So it's up to a modeler to see whether what the model is doing is right or not. Does it make sense or not? If it does not make sense, the modeler needs to revisit the model, fix that thing and rerun the model. So this phase is also interesting because it gives you the opportunity to interact with a very broad audience. So in some cases, you will be interacting even with the CEO. So now let's look at how we are going to present the results. So in the first dashboard, the cost savings dashboard, we have put the total transportation cost, warehousing cost, and the total cost. And these information has been put for all the different scenarios. So the purpose of this dashboard is to provide a high level overview of the results. What we are observing here is that the total transportation cost actually is lowest in the Hosur closing scenario and is second lowest in the plant warehouse scenario. Similarly, the warehousing cost actually is highest in the Nagpur DC scenario, maybe because we have too many distribution centers in that scenario. And the next is the total cost. Now we see that the total cost is lowest in the Hosur closing scenario and second lowest in the plant warehouse scenario. And if we look at the savings numbers is highest for the Hosur closing scenario, almost $1.4 million. So now there is an important thing regarding savings calculation. So you need to understand how the savings is being calculated. So now if you look at the optimal baseline savings, it is being calculated by subtracting the total cost for optimal baseline from the total cost for actual baseline. So this tells me that if I change my network flows as proposed by the model, I'll save around $700,000. For the Nagpur DC scenario, the savings is $300,000. So this saving is on top of the savings from the optimal baseline. So what this precisely tells me is that the net value of creating the Nagpur DC, the additional savings because of creating Nagpur DC is $300,000. Similarly, the additional value from plant warehouse, creating plant warehouses is $900,000. So again, this $900,000 is on top of the savings of the optimal baseline. So all the savings of all the different scenarios are being calculated based on the optimal baseline. So now if you would ask for the total savings, if we change the flows as well as build the plant warehouses, it should be more than $900,000. It would be approximately $1.6 million. But the savings due to the plant warehouses being created is $900,000. So this is very important and you need to understand and you need to be sure what you are presenting. So if somebody asks you what is the total worth of this project, you might want to represent the cumulative number. But if somebody wants to know the value of a particular strategy, you might want to report this number. So now this gives you an overview. Let's move to the next thing, that is the plant production. Now this was one of the objectives of our project. Now this is a very interesting analysis as well. Now if you look at it, so the two plants, so the first plant is plant Haldwani and the second one is plant Sananand. And these orange lines represent the capacity of the two plants. So now what we see is, as we allowed the model to freely determine the flows, what happens is the plant at the Haldwani is being highly utilized. So basically overutilized. The utilization is more than 100% in almost all the scenarios. However, the Sananand distribution center, it is being underutilized, almost maybe 50%. So now what this means is that the model is actually preferring capacity at the plant Haldwani. So this actually gives you an indication that there needs to be a readjustment of capacity between Sananand and Haldwani. The capacity at Sananand can be brought down and the capacity at the plant Haldwani needs to be added, the production capacity. So now we can use the numbers recommended by the model as a starting point. So say for example, if we pick this number, the plant warehouse scenario number 129,000 flow for Haldwani, we might want to put a buffer on top of that, maybe a 20%. That is something that design team determines. Based on that, we'll determine a final capacity for the warehouse. However, the message from this exercise is clear. You need to readjust capacity between Sananand and Haldwani. So now let's get into flow analysis. So now this is another very interesting thing, and this is very important from a modeler's point of view. So I told you how as a modeler, you need to analyze individual flows between the distribution centers and the customers, and at the same time, the flows between the plants and the distribution centers. Until and unless you analyze all the flows, you won't see whether it makes sense or not. So let's pick up a few examples here. So let's say for example, this one. So what we see is in the actual baseline, Bhivandi was shipping to the DC Bhivandi was shipping to customer Bhopal. Now it is being shipped from distribution center Rewari. So now what can be the potential reasons for this? So one potential reason can be that Bhopal is closer from Rewari compared to Bhivandi. So now let's actually look at the maps. So I have prepared two maps as well, just for the actual baseline network and the optimal baseline. So you can create similar maps for other scenarios as well. It's totally up to you. So if we look at the actual baseline scenario, so this is somewhere where the Bhopal is. Now this place actually is closer from this distribution center, which is Rewari. So now let's look at another thing. So what we can do is we can play around with other scenarios as well. So we can select, say, actual baseline and Nagpur DC scenario to compare, or maybe say even optimal baseline, and let's remove actual baseline. So now we are comparing the Nagpur DC scenario and the optimal baseline. So let's look at DC Nagpur. Let's see. So we see that Nagpur is being shipped from the DC in Nagpur, which makes total sense. Then we have Raipur, which is being shipped from Nagpur. So now you need to analyze whether this flow makes sense or not. So it might seem difficult at this moment that how would I remember hundreds of locations and how would I go and individually check maybe thousands of flows. But once you actually start working on network design projects, and when you actually work on a number of network design projects, you actually have the network of the company in your mind. So simply by looking at a flow, you can tell whether this flow makes sense or not. Similarly, Vijayawada and Visakhapatnam are also being shipped from Nagpur. Similarly, you can also select, say, inbound. So now for inbound, you have the plant Haldwani and you have the DCs here. So now the purpose of showing such a thing was that you understand how you have to actually analyze individual flows. I could not show it in much greater detail because it's a very, I would say, time consuming thing. You have to actually go individually into each of the flows and then analyze it. However, hopefully you get the sense of what I'm trying to tell you. So in this way, you will analyze the flows. You will understand whether the flows make sense, whether they tie up into the overall cost numbers or not. If there are any anomalies, you change it, and then you actually rerun the model, reanalyze the results. So it's in many sense a repetitive process as well. So I've already shown you the maps. So these are the maps that I had created. So maps are a very good way of actually representing data. So that's a very simple map. However, you can also create, say, heat maps. You can put some pie charts on the map. So there are different ways to actually analyze it. And it would be good if you actually learn those things as well. So now that I have explained how to analyze and present the data, that's all in this entire project section. So let's quickly summarize what we have learned by working on this project. So we learned how to create different scenarios. How should we decide on which scenarios should be evaluated and which strategies should be evaluated? We learned how to prepare the data, how to perform basic checks on data. We also learned about building the baseline, running different scenarios, how to combine the scenarios and the baseline together and analyze the results. So let's close the project here. Hope you enjoyed working on this real life supply chain project and hope this was a fruitful experience, a learning experience.